may be times when you want to break out of a loop right away, even if the loop condition doesn't at that point in your code actually evaluate to false. Well, you can do that using the break statement. Just as break was used to make an immediate exit from a switch case block, so too it will cause an immediate exit from a block of code that is run in a loop. Now look at this code. The while loop here has been set to run as long as I is less than 10. But inside that loop I testify as 5. And if so, I exit the loop straight away with break. This means that in spite of the while condition expecting to run the loop for 10 times for values of 0 to 9, in fact, when I is 5, the loop stops running. The code following break is never run. So let's see what's actually displayed when I run it. So I is 0, 1, 2, 3 and 4. And when I is 5, break is hit, so it doesn't even execute this printf statement down here, it exits the block straight away. Now be careful when breaking out of a loop in this way. In a more complex loop containing many lines of code, the break condition may not be obvious, and it would be easy to assume when you look at the code that the loop is guaranteed to run while I is less than 10 because that's what is stated in the test condition up here. As a general principle, it's best, that is clearer and less bug prone, to avoid breaking out of loops unless you have a very good reason for doing so. Now let's look at a slightly more useful example of a loop that uses a break. You'll find this code in the 02_break and continue project in step 6. Here I want to look at the forBreak method. This encrypts a string by adding 1 to the numeric ASCII value of each character in that string, and that's in the char array variable. And then it creates a new string, str, from the encrypted characters. Suffice to say, this is about as simple and, let's be honest, insecure as an encryption algorithm can get. You certainly wouldn't want to use it if you were working for the CIA or some other organisation to whom secrecy and security was important. Even so, it serves to illustrate the basics of how to process strings or arrays of other data types using loops. My code here can handle strings of up to 50 characters in length. And I've declared the string data type that I'm using to be 50 in length. Now, in principle, these might be strings entered at the keyboard, or they could be read from a file. But for simplicity, I've created a string stored in char array, and there it is, declared up there. Hello world, exclamation mark, then a space, goodbye. As I want each string to have a maximum length of 50 characters, I set up a for loop to iterate over the characters from 0 to 49. However, the actual length of each string, and I'm talking now if you were reading a string from a file or being entered at a keyboard, in which case I wouldn't know in advance what the string length was, well, that might be less than 50. So I've made it a requirement that each string is terminated by the exclamation mark character, and when that character is found, the standard C string terminator, that's a null, is substituted, and the rest of the string is ignored because at that point I break right out of the for loop. Now this means that if a string has only 10 characters ending with an exclamation mark, the for loop will run only 10 times, as it will then exit on break, even though the loop itself is set to run from 0 while I is less than 50, so it could run up to 50 characters. Let's see this running. And there you go. First of all, it encrypts the string and then it decrypts it. But the important thing to notice here is how the string has been terminated. Remember that I broke out of the loop when I found the exclamation mark character. Here you can see that my string was terminated on hello world, whereas the actual string had hello world exclamation mark followed by a space and goodbye. So that's how break has helped me to find the designated terminator and to break out of the loop when it's located it. There's more going on in this program than I've covered here. There's something quite interesting going on with this continue statement, for example, and I'll explain that in the next video.